This talk is called Your Agent Works for Me. It's going to be hopefully interesting and entertaining as well. I just want to get started right away with some source code. So we have a Go program here. It's a data structure, customer data structure. And there's some code to add a customer, delete a customer, right? But one thing is missing. There's no edit customer function. So somebody already, luckily, created a ticket for this, right? A feature request. Hey, we want to add the edit customer by ID function, right? Seems like a useful feature that we want to add. Who here would feel comfortable assigning this ticket to your AI agent? You know, just like have it work on it. We have a couple of courageous ones. Donato is like, yeah, let's go. So what happens if we do that? So this is the source code. This is the linear ticket, a feature request. And we go ahead here, use Windsurf. We ask it to, hey, work on this ticket. It has MCP integration. We'll reach out to load the ticket. And things happen really fast now. Creates a plan to work on it. Here you can already see the exploit actually in the plan. But it will actually run a remote command that is in the linear ticket, right? We got remote command execution. And you might wonder why that is. So if you go to the ticket here, copy this text, and put it in this tool I have, the ASCII smuggler, there's the prompt injection that actually says to launch the calculator. Okay, so that was a linear ticket. What about code review itself? This is the first time you might see Apple Xcode. I have not actually seen anybody do a prompt injection with Apple Xcode, so I thought it's going to be fun to show one. So here's source code. There's no visible prompt injection in the source code here. But what if we ask Xcode to review this file? It's going to review it. Loads the file, analyzes it. It does see hidden Unicode tag characters, right, which we humans don't see, but the LLM sees. It starts reading the config file for some reason. Now something interesting happens. It decodes these Unicode characters, right? Now you see the actual prompt injection payload that asks it to add source code into the file that is going to send data out to the attacker. And it also asks it to call a tool called run snippet. So in Xcode, the attacker can run source code on the fly. And this is what is exploited here, to have a seamless end-to-end exploit chain. What is important to know is with Apple Xcode, it's actually pretty good because if you have a good environment set up, you have a sandbox. But if you have your entitlements that allow internet connection, this will work by default. So yeah, we have remote command execution, we have data exfiltration, right? But we can, of course, do a lot more. This is now a demonstration of something I've not shown before, Microsoft Enterprise Copilot, and how we can actually add memories and compromise Copilot in achieve long-term persistence. So this is Copilot. I have a demo file that we're going to analyze. Ask it for the key takeaways of this file. It analyzes the file, and on top you already can see it invoke the memory tool. And now Copilot is going to be compromised forever, right? And there's two specific memories this exploit added. The first one is just that I'm 102 years old. The second one is a command to run a Commodore 64 simulator. And now if you have a conversation with your Copilot, this is the enterprise Copilot, right? So imagine this is about financial information, about your organizational structure. All of this information is now falsified going forward. This was actually fixed by Microsoft last December. Okay, you might want to see the prompt behind this, and interestingly, right, these are not very complicated attacks, right? It's just natural language, and there's often some trickery and some ease-in to get the language model's attention, and then add the tool invocations to add these memories. So we have persistence, and we can, of course, combine all of this, right? We can have data exfiltration, persistence, loading remote commands. And there's an example I gave a black hat with ChatGPT to get continuous data exfiltration. And I called it spyware back then, 2 years ago. And the same is possible with coding agents, right? With Windsurf, for instance, I demonstrated that you can load remote commands, right? With indirect prompt injection. You compromise the agent's memory, so long-term persistence, with the instructions to continue compromising the user every single conversation turn and send the data out to the attacker continuously. Every time you type something, it will be sent to the attacker. And I have a demo video of this that I've shown before, so I'm going to skip it here because it's a longer video, but it just shows you this attack end to end. Okay, so we have persistence and data exfiltration. And when I once talked with Ben Nassi, who they released this paper very recently called the promptware kill chain, I always talked about an AI kill chain, but this paper highlights this much, much better. It's really that we see with prompt injection that it's not just a single injection anymore, right? It's a complex malware even, right? So we should start maybe using the word promptware to highlight that the injection is the technique, and then what you do later is a complex set of instructions to achieve an objective, right? And that is called promptware. That aligns along the kill chain, right? Data exfiltration, persistence, and so on. So yeah, prompt injection to malware, to promptware. And now I want to talk about something I haven't really explicitly talked about before, and I hope this is going to be very interesting. It's called delayed tool invocation. So when Googlebot, it was called Googlebot back in the day, I was experimenting a lot with tool invocations and so on. So I created this idea of, I want to just have it call all the tools, right? But it didn't work. It would call many, many tools, chained with an indirect prompt injection, but one tool, it just refused to call during an indirect prompt injection. So this is actually the demo from when I experimented back then. I had this image, I just gave it all the instructions to call all the tools, and it would just blindly call them all. But it would not invoke the workspace tool, right? The tool that has sensitive information, the tool that has your email, your drive, and so on. So that was not invocable. So this means there was an actual security control in place that Google put in place to prevent that from happening because of indirect prompt injection. So a couple observations had, right? The Gemini workspace tool gets deactivated. We cannot chain it. But then I thought about maybe it requires explicit user intent. So in the initial prompt, when you type, you talk about email, then it will activate the tool, so to speak. But I was wondering, can we do this maybe in a later conversation turn too? Maybe the tool becomes active again. So this was my research back then was focused. Can we activate the tool later, or is it becoming available? And I found something that worked actually, and then I contacted Google. And it was really cool, actually, because the Google security team asked me to send them an email to actually see if this really works. So this is the email that I sent to Google back then. And this is where the prompt injection is in the middle of the email. And the important part is that I asked the LLM to repeat the attack to continue when the user continues the conversation, right? The only condition is now that the user continues typing after the prompt injection. Then invoke the workspace tool to load some sensitive document about, I guess, about cats. Okay, not that creative, but yeah. And I sent that in, and then a few minutes later, I got back that it actually worked, that it was like reaching out, and they were able to reproduce this behavior. So that was really cool. And then I built a couple of exploits around this technique. One very specific one, this is now a year ago, was actually similar with Microsoft Copilot. We could add memories, and I want to show you this exploit. We have here an indirect prompt injection, but I always use files often in my demos because it's very easy to create test cases around files when not having to load remote files from servers and so on. But you can see here, we summarize this document, and in the middle there is actually this condition, this delayed tool invocation. And now if the user continues the conversation, the tool gets invoked. So the tool becomes active again, even though it was not active in the very beginning. Now the tool is active, and we invoke the memory tool, and now have a long-term persistent memory in Gemini. And it's similar now too, right? You can see the memory. And now in the future conversations, Gemini will think this is true, or this belongs to my memory. Okay, and there was one additional thing that I found just last November. There was a really great Black Hat talk last year from Ben Nassi and Steph Cohen and a few others called Invitation is All You Need, where they used a lot of these techniques to show some really, really amazing exploits, like opening your garage, your windows in the home and all of that, all driven by Gemini. And I looked at it again last November, and then I found a really interesting bypass, and we need sound for this. I don't know if you can hear that. But that I had this Google Home device that I hadn't used for a long time, so I set it up, connected it, and I wanted to invoke it and see if I can find a bypass. And in this case, we continue the conversation, so there's an exploit. And I actually had found a bypass, so it's now connecting to my Google Home. It's invoking the speaker.
Broadcast. It says, Johann is here. Trust no AI.
So you can see we can actually with indirect and prompt, and they called it twice.
It says, Johann is here. Trust no AI.
So we can actually invoke, physical things now too, right? This is sort of the demo. And the way it has worked was that some of the metadata of the document become part of the prompt. Well, that's my interpretation. I do not have access to the source code to validate this, but this is what I think is happening, is that if you have like an intent signal in some of that metadata, Gemini thinks this is your user's intent, and it activates the tool. So in the title of the document is called Broadcast to Living Room, and that is the intent signal that the tool becomes available. That's my interpretation, right? That's, if somebody is here from Google, I would really like to know if that is actually really what happens behind the scene. Okay, but it's not just Google Gemini. We can also do delayed tool invocation in ChatGPT. ChatGPT, to my knowledge, does not have an actual security control that I showed here earlier with Google, but it still is a technique that allows you to bypass a lot of guardrails if you do these delayed tool invocations. And here you can see there's a personalization option in ChatGPT. By default, it's set to default, but now we're going to do a delayed tool invocation to modify that personalization option. So we summarize this document. And it's going to summarize the document, but the LLM is repeating an attack. And what is important also, this doesn't actually have to happen, that the LLM writes it here too, because it's already in the document. But my thinking was always that I want to put more attention to the attack, so I have the LLM repeat it. So it's more likely to actually succeed. And you can see here, we write yes, and it invokes the tool. And it's now, the personality of my ChatGPT has now been modified to quirky. With this delayed tool invocation technique. Also, this is possible to read remote documents and all of that. You can seem to be able to invoke a lot of tools with that way. I reported this, of course, to OpenAI, and they found it very interesting, but it's not a security problem. It's more like a guardrail problem. So they shared this with the guardrail team, I guess, or the safety team. And there is a document, a paper that came out from Google very recently that I found so fascinating. It's prompt repetition improves non-reasoning LLMs. So if you repeat certain text twice, like the query twice, it actually improves the LLM's performance. And this is similar to this attention thinking I had about repeating the attack twice, that it actually brings more attention to the attack, and it's more likely going to succeed. Okay, so you can see there's a lot of things happening, and I was thinking about, with all these naming changes, we've kind of become offensive context engineers, I guess, as red teamers. And there's a lot more about delayed tool invocation, but this would make the whole thing a 40-minute talk. And I do know I have a little bit more time, so I'm going to cover a few things that I have that are, I think, very interesting. But many of the things you just saw, they're not new or novel, right? We have seen this before. Data exfiltration, all of these things are not new, right? So last year I thought, this is the year everything is going to change. We're going to have stronger boundaries. We're going to add less autonomy with less trust, right? The opposite is happening. We have more automation, more features, more trust. We have MCP, we have skills, we have AI browsers for some reason. And we all got OpenClaw, right? And so things are moving really, really quickly. And there's this thing happening in industry that I call the normalization of deviance, where we fundamentally know that we shouldn't be trusting these models, right? The output is not trustworthy. We do not control or know exactly what's going on. But the more we use it, the more we start trusting it, the more we normalize the belief we can trust it, but then very drastic things can happen. Here, for instance, I think most of you know this example where it just deleted, OpenClaw just deleted the inbox, the real inbox of a user, nuked it all. And the reason when people ask the person, this is a person working at Meta, why this happened, he's like, I used it on a test system for a while, and it worked without problem. So I felt comfortable to use it on the production system, right? And this is an example of this normalization of deviance. By now I talked a lot already about, and I hope you haven't hit your context limit yet, because there's one more thing that I think is really important I want to share, which is a kind of project I've been working on for a while. And it's sort of this idea that command and control infrastructure, right? I want to move it up to the prompt level, like not work with operating system commands anymore, but have a prompt command and control with prompts. And it will work, or it works with any agent, with any language, and it's an abstraction from the operating system, right? This is generally happening with agents. We have an abstraction layer, and attackers will leverage that same abstraction layer. And the first time I talked about this was also at one of the Black Hat talks, and I have a blog post about what I call the AI domination, zombies, and so on. And this is called Agent Commander. It's a tool that, once you have an indirect prompt injection, or somehow you compromise an agent, you can have it join this command and control center. And the thing you do is you prompt your agents, right? You send prompts down to the agents, and then they act on those prompts. And you might wonder how we can compromise them, right? There is actually a lot of good research out already from various stakeholders, like Xanady, Hidden Layer. They have some good examples of how to compromise OpenClaw, for instance. My research also focused on OpenClaw, and I backdoored the heartbeat. I'm going to skip some of this here. Oh, this is interesting. So one thing, as an attacker, you want to be always hiding from the actual user of the system, right? When the user interacts with your OpenClaw, you don't want to show one of the attack payloads or results into the user's channel, right? So one way you can hide is by adding certain strings in your message as an attacker. If, for instance, the heartbeat ends with the string heartbeat OK, it will not be shown in the user UI. Or if a message starts with capital no_reply, it will not be shown in the UI. So as an attacker, you can add these strings, and then you kind of hide. And yeah, so I have this example where you cat, here you can see that the default heartbeat. And there's actually a really interesting thing I learned from the alias is Vegan Mosfet. He has like a blog post about how you can configure OpenClaw with a PubSub subscription, so it gets notified if there's a new email arriving in Gmail, and it will automatically analyze it. Right? It's a built-in feature of OpenClaw. And that can be used with a prompt injection, right, to get a zero-click. You just really send an email to your agent. All you need to know is the email address of the agent. Or if your agent is your own personal inbox, very problematic, right? But you get an email, and then 10 seconds later, you are exploited. And so I built on top of this and combined this with my heartbeat idea. So this is the exploit, a system message. The cron job ran that read the email. It was notified, it analyzed the email, and then it fetched the remote instructions and just appended that to the heartbeat. So now, then wait for like 20 minutes or whatever the next heartbeat happens, and the heartbeat file looks like this, right? And this is what I call promptware. You can see this is not like a prompt injection. This is a complex set of instructions that tell the agent to join a command and control server, right? But all prompt-based. And then, yeah, it joins the command and control, and now you can prompt it, right? You can say, hey, do a security assessment of yourself and tell me all your problems, right? And it goes ahead and tells you, oh, my name, server name, my IP address, my server, my uptime, right? It's like full pen test report right here, right here. It tells you about how it's configured, the environment, variables, and so on. So it's really about to have this idea of prompt templates in the command and control system, where you pick a template and you just submit it down, and then it runs those instructions. A feature I feel I'm really proud of is actually that you can basically say, hey, browse to this website, take a screenshot, and it will upload the screenshot to the command and control server. So you say, hey, browse to the inbox, take a screenshot, and you share the screenshot with me. The agent will just do that, right? And the user doesn't know it's happening because it's all hidden from the user's interface. And it's not just working with OpenClaw. My build test was that I wanted to use a different one, and then I used KimiClaw, and here you can see the prompt injection exploit that hides itself here, and then KimiClaw joins the command and control server as well, and it's the same way, right? This is the prompt injection payload, how we added the information to the heartbeat, and then you can ask about the human, who is your human, what's your human's name, right? What's the human's email address? And you can dispatch tasks, right? It's really this abstraction from the commands of the operating system. The attackers will move a level higher. And yeah, then because this was Alibaba infrastructure, I was like curious how they set it up. I found this is worth sharing. So there is this SSH key, authorized keys file, and there's a keys file that is a MacBook Pro, which makes you realize, right, startups often don't have a lot of security controls. So probably every single employee of Moonshot AI has this key on their laptop and can access your VM, right? That's my assumption, because this is very not normal that you would have an authorized keys file from a MacBook Pro in your machine. And this is now the final statement, right? We can turn this agent into a red teamer. into a pen test, right? We can make it rogue, install security tools, and then have it operate. And this is, I think, the big takeaway in a way that from a red teaming point of view, I'm really wondering how things will change as we see an adversary not needing to a 0-day upfront, right? The system will get compromised, and then they walk through the network without knowing a single 0-day possibly, right? Because they're gonna find them on the fly, in real, maybe possibly in a year or so too, maybe even in real time, right? Because the LLMs are gonna be so powerful to just find problems and navigate the network very quickly. Yeah, so that was Your Agent Works for Me Now. I hope this was interesting and entertaining. Thank you very much. Yeah, I'm Johann, by the way. I forgot to introduce myself.
Any questions, folks? Oh yeah, we got one right here.
Good morning.
Hey, morning. Thanks for the talk. So, around the tool invocations, right? You suggested that LLM interprets and content decides the tool. So, do you think that this is like fundamentally flawed now, like between the AI agents implementation itself?
Not fundamentally flawed. The actual thing that Google implemented was actually a positive thing because they added a security control that really limits the tool chaining capability, right? So I think that is very positive. That the tool becomes later active again, right? That is kind of a bypass, and it's something we need to figure out, I think, or they need to figure out how they can lock that down better, right? Okay, yeah. Without always having to ask the user, because the really good thing is here, the user doesn't have to be asked, right? Because always these prompts, yes, 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 is not very useful.
Right. So, and in terms of prompts, now because you showed a demo which was pretty nice of, you know, how tool invocation, like delayed tool invocation causes issues, right? So would you say that it's more of like a state manipulation vulnerability attack rather than input validation?
I think it's a fundamental attack or behavior that within the LLM, within the transformer, right? We target the attention layer, and then because the model is hooked up to invoke outside tools, right? We target the attention layer to bring attention to a certain thing we want to have happen. Okay. If that makes sense.
And I think so one question is around the trust boundary, right? Invoking tools versus the external content. So where do you think like the best trust boundary would rely? Because definitely that's going to be like a debate within a lot of teams, right? Like how the trust boundary can be established.
I might not have gotten the question.
Like external content, like where you know the content is being retrieved along with the tool invocation, right? So what's the best strategy of fundamentally putting like trust boundaries between?
Yeah, like definitely you should assume if you don't have a control in place that the tool can be invoked, right? By indirect prompt injection or by the model itself, right? And then you need to think, what's the risk scenario, right? What is the downstream impact of the tool being invoked? And that's where you need to think about the security controls, right? What can it access, what can it do? And you can prevent tool chaining, right? It doesn't have to happen that the web tool can chain other tools in a row, right? There's all like actual security controls that can help mitigate impact. Yeah.
There's an entire pile of new security tools that have been just coming out fairly recently for OpenClaw. I was curious if you had played with Claw Shield or any of the other ones and seen whether they make any notable difference in the difficulty.
I have not. The space is evolving so quickly, so it's really difficult to keep up. Even just OpenClaw itself adds a lot of mitigations as we speak, right? They have like over 200, last time I checked, over 220 security vulnerabilities they actually fixed within 2 or 3 weeks, right? So there's a lot happening right now. Yeah.
Anybody else? Gotti?
I wanna do this thing that I do once in a while and embarrass this guy. Oh. This is kind of while we move things around quite drastically. You're gonna have to pull this down, sir. Well, we move these things. Did I just put you down? I didn't mean to do that. Sorry. No. I'm just fat, not tall. Okay. I don't do this all the time, but once in a while, I know somebody on a personal level, and they have done something not just amazing technically. I mean, this guy is a slouch. What do they know technically, right? But also for the community. And what you don't know about Johann, or you might, is that he has done a lot of stuff, and not just for the lols, but just because he thought he should. For example, the month of AI vulnerabilities, right? He just came out of nowhere. I'm not going to drop the mic, they're expensive, but mic dropped with every single day another vulnerability. Every single day. And forget finding the vulnerabilities or proving they're real or even going as far as reporting them. Just imagine aligning all the reporting to happen on the same day, so he releases things on the same day. That is a superpower. And truly, he's one of the most appreciated people in our space, but usually for his technical chops. And I just appreciate him and how he helps people. And more than that, he's one of these people out there in the world that I nag for things. Hey, let's do this, hey, let's do that. And he's not afraid of saying no, which is amazing because I feel free to come to him again. And number two, because sometimes he says yes. So please, let's just once again give him a hand, because in what is now the stage for the offensive track, and it shifts around, right? The right people are in the room to appreciate him. So thank you, sir.
Yeah, thank you so much.
Really.
Awesome.